All right. I guess I'll share my screen if it'll let me. And there we go. So we need to find the potential function for f.
I think I've done that.
All right. I'll just rereading up on it.
It's exciting that we get to work together on the test.
Oh, we do? I haven't even looked at that yet.
Yeah, on the week 12 overview, it says at the start of week 13, you have 2 lessons due by Tuesday.
Yeah, I only read that part.
No group quiz, but a take-home test that you should work on during the group meeting.
Well, that's fun.
Yeah. Do you think we should plan on just having more time available to work on it together, or do you just want to work on it our normal amount of time and then go off on our own?
I don't know. I think doing it together as long as we can is probably the best. I'll try to hit it up and do some of it before, at least attempt it, But I don't know. I know your Wednesdays are different than mine, but I've got most of the time I can meet. Or sorry, Thursdays is what I mean.
Mm-hmm.
Except for at night, I've got a computer programming class, so I can
Well,
meet for however how long until like 5 p.m. ish, so I can get ready for that class.
if I plan on it, I can be as well. Hopefully, it doesn't take quite that long.
When does it become available? Next week when we can look at it?
I think so.
Okay, how about we look at it Monday and then we decide how much time we think we're gonna need.
Okay.
But I would say at least plan maybe 3 hours minimum. So if we went from like 10 to 1,
Yeah.
I know that's a long time. I mean, we can take a break in between if we need to grab stuff to eat or whatever you need to do. But maybe if we plan for that minimum, that should help us a lot. And then we can always meet again. When's it due? Friday?
Saturday.
Oh, Saturday. And we could always meet again if you have time available later. But I think if we can get 3 hours done, that might work. All right, let me reread this again because I didn't get very far Tuesday. I was going to catch up yesterday, but my eyes are kind of blurry right now, so it's a little hard to read. So we just take the derivative. Is that what we're doing?
The derivative?
Yeah, to get the potential. Or is it the opposite? I can't remember. Let me read.
It's the integral.
Oh, the integral. Yeah.
You worried me for a second. I was like, wait, did I do it backwards?
No, you did it right. My brain isn't functioning right now.
Dude, I feel you.
So that's just with respect to x. So, excuse me. So that's going to be 4yx plus 3zx in the I direction. And then it's going to be 4xy plus 2zy in the y direction.
Yep.
3xz plus, is that 2? Oh, I can't read. I even put the wrong thing down. 2yz. So, doesn't want an IJK, does it?
No.
Okay. I hate IJK notation, but that's just me.
I don't mind it, but sometimes I'm not sure when to use it.
I just like the vector notation just a lot cleaner, at least for me to see. Oh, oh yeah, I got it right. Okay. Awesome. Apply Green's theorem.
Wait, what did you get just to make sure?
Oh, sorry. I thought you were looking at my screen. So I got 4yx plus 3zx, 4xy plus 2zy, 3xz plus 2yz.
Yeah, that's the wrong notation. I mean, it's almost there, but
So I
first
need,
off, you should combine like terms, and there shouldn't be commas between them. There should be pluses, and there needs to be a C at the end.
because of the integration. Oh, my heck.
Use the C as the arbitrary constant.
Interesting. I guess I wasn't thinking of that. So let me redo that then.
Well, I mean, it's just literally putting in pluses. So I ended up with 8xy plus 6xz plus 4yz plus C.
Yeah, that's what I have too. Okay.
Yep.
Let me rewrite that. That's quite a bit more simple than what I just did.
Yeah, I was thinking it was going to be complicated, but that first problem actually wasn't. However, now we're getting into Green's theorem, and I did not understand it at all.
Yeah.
For Green's theorem, I literally just went through and put in the answers it wanted.
There you
I
go.
did not understand. I used the power of deduction.
What's it asking exactly in here? Let's see. So we've got this curve. So we have to parameterize it ourselves, I'm guessing. It's kind of weird. I can't remember. This is what I kind of studied up last week for the quiz, and then it was on the moment of inertia, and I couldn't remember how to do any of that stuff because I focused on flux and everything else. Okay, let's see.
I just don't know where that notation is.
Which one? That with the circle?
Well, I don't remember seeing that at all in the homework. But
Yeah. So
also,
the circle means it's you're integrating in regards to a curve, and it's really just a closed loop, and the loop doesn't cross itself at all. Could be any shape, whatever, but it just goes from beginning to end of a curve or a circle, essentially. So that's all it's saying right there. But now I'm trying to remember.
but like, are we trying to find the flux, the circulation?
Um,
I don't know what we're trying to find.
I believe. Let me glance at this again. Let's see. I guess yeah, circulation is what it is. Now let's see. Wait a minute. Circulation density. What? Let me see. I can't remember. Hmm. I just know it has to do with the slope. basically of the curve, but it's I'm trying to think how to word it right. I know I can't really word it correctly because I'm not sure what I'm trying to say.
Yeah. It really frustrates me when he asks for something that he doesn't include in the homework.
Yeah. Yeah, usually C is already in like the parameterized form, then it's easier to do. But I don't know how to do r squared with the x minus 5 and y minus 8. I guess it's still going to be would be square root 2, right, for r?
I'm not sure.
Let me think this through. It's just really odd how it's set up. Let's see if it says anything else in this one. Let's see. I just can't think how to do this for some reason. I don't know why it's being a pain.
So we need to take the derivative of both of them. So
So we get big F and we get
1 and 1.
Well, if you take the derivative, gosh, I don't know, my brain, because this is different than what I remember. But so take the derivative of the circle, I think. I don't like how C is like that. That just throwing me off.
Okay.
So anyway, if we take the derivative, do you get
Okay. Well, so the radius is r squared. So it'd be the square root of 2.
right? Yeah, that's what I have.
And then the h and the k just represent coordinates, which is useless information to us right now, right?
Well, I can't remember. Do we plug that in as a cosine whatever minus the 5 and sine minus the 8 inside? Theta minus 8 and theta minus 5. That's what I'm trying to remember. That's why I'm having a hard time because I haven't really ever done that. Well, if it's going to be a circle, we know that the bounds are between 0. I'm just going to do theta is between 0 and 2 pi. R is between 0 and square root 2, right? Would be the positive square root 2. Our RT should be I don't know what about the -5 and -8. That's what's throwing me off. But I would guess RT would be something like cosine theta and sine theta. Yeah, I don't know though. Gosh. Let me go back. Oh, what's this lesson? Surface. Yeah, it's this one. Yeah, I know. Maybe I'm making this more complicated, but I swear I have to do something with the curve. Let me read this. Plane. Man, I'm not quite sure.
Oh, wait a second.
Because I thought it was going to be a double integral, but he has it kind of split apart,
Mhm.
I don't know. I'm having a hard time. Just. So do we only do it in regards to the radius? I don't know.
Not sure either. I'm getting there. Or I'm trying to get there, but
Yeah. It's just weird that circle not parameterized and then the integral split up like that. Hmm. Hmm.
I'm sure that has an effect. I think we just assume it's R. The derivative is 1 and 1, so
I can't. I'm gonna Google some. Alright. I mean, if I can see an example, I'll know what I'm doing exactly. But oh, maybe it's not gonna open up. Oh, here we go. Here's how we mix them together for a double integral. I knew there was something, I just couldn't think of it. So that's what we need to first do to rewrite them. So let me go back to this real quickly. So it's the okay, I'm gonna go back. So that's gonna equal so that one should be 6. minus 9. How did they have that? Let's go dy dx. So now I've got a double integral, which is going to be -3 dy dx. And it's a circle, so it's 0 to 2 pi, and the radius is going to be 0 to square root of 2. Dy dx is going to equal r d theta.
I came up with 2 pi, and I don't think that's right.
Well, I've got a negative number now, and I'm pretty sure that's wrong.
I'm pretty sure that's wrong too.
I don't. I was just trying to follow this form on there, getting it set up, and then after I got the integral set up, then it works, except for it's the negative.
Yeah, the circulation was never negative. Sometimes it was 0. But
Well, I think if it's negative, it means. What's it mean?
it's going.
Oh, that's the flux. Sorry, never mind. Yeah, I think it means I did it completely wrong. But I'm just gonna solve it anyway and see where I get how my answer compares to yours.
Like I said, I just got 2 pi. So I think I did something wrong.
I'm actually not that far away. The only thing I'm off is a constant, it looks like. Because it's root 2 squared over 2, that's 1. So,
Yeah. And if you do 1 with regards to 2 pi and 0, it becomes 2 pi.
yeah, and that's exactly where I'm at. Is 2 pi, but it's times a constant, which is -3 in my case.
Wait, how'd you get -3?
Um, it's a good question. So if you're looking at the screen, there's this formula where you add them together, right? You
Yeah.
put the q term partial x in the front, which
Wouldn't that
is
make 1 minus 1?
no. So your p term, you have to differentiate partially with respect to y. Because
Oh,
you have to, they both have to be dy dx to put them together.
gotcha.
Yeah, so that's what you have to do there. So what I got for that one was 9, and that one goes in the back term. So I got a 9 there, and then I got the q, which is y plus 6x, and then dx of all that's going to be 6. So I get 6 minus 9.
Okay.
That's how I got it, but I don't think that's exactly right. I'd feel better if it wasn't so negative. Oh, here's one that might help. The only thing difference is that the radius is 2 instead of square root 2.
Yeah, I looked at that one.
Oh, did you already?
Yeah. That makes more sense now, though.
Yeah. And it's some constant times that. Whatever the constant is. I don't think it's -3, but that's what I'm getting.
Well, they got a -3, and I can see where it came from.
Yeah.
I don't know why they're doing r cubed, though, instead of just r. That's the only thing I'm not sure about.
Okay, so this is something we forgot to do.
What?
Um. Oh no, it's not. No, we did it. We did it right. I don't know, that curve is confusing me. So what they did is they took the derivative, and so they got their 3's out,
Yeah.
and then
How did they turn x squared plus y squared into r cubed?
so this is r squared, right? X squared plus y squared. Although I don't understand the y term, shouldn't that be a negative? But anyway,
No, because they took out -3.
well, the y term's positive. This is negative, but that's not.
No, because it's y3 dx. Look at the one above it.
I know, but I don't understand why the y. I still don't understand why y is negative. Oh, because you were mixing the terms.
Yeah.
Gotcha now. Gotcha. So anyway, so they just factored out the 3 from there. So x squared plus y squared is r squared. dA is the same as dy dx, which is the same as r times dr d theta.
Oh, because it becomes r times whatever is left over. But in our case, we only had we don't have anything left over, so it
Right.
just becomes -3 and the integral of r.
So I'm saying negative 6 pi, which means that we're looking at it in the wrong direction is all it's saying. Right?
Well, can you scroll down a little bit?
Yeah.
I want to see what their final answer is. They left it in the negative, so I think it's possible. So let's go with -6 pi.
Okay. Right? It just seems so weird.
Like I
I
said,
can't see anything else, can you?
no. I just wish that he would give problems that were similar to what we worked on,
Yeah.
not completely left field.
Right.
Oh boy.
Oh, I don't like the sound of that.
I don't know if I looked at this homework.
Find a parameterization of the surface between the planes. What is the correct parameterization?
Oh geez, there's 20 questions on our homework due today. Oh, but they're all multiple choice. That's fine.
Well, we have a lot today. Because what? We have 4 reading assignments?
I'm gonna be honest. I haven't read at all this semester. I learn from my math lab better than I do from my math textbook.
Yeah, I've been watching those videos when
The
I can get them
video,
to work.
the videos help sometimes.
Yeah, the last little bits helped quite a bit, actually, for me. But yeah, reading on there is really confusing. So it just usually I do the homework first. The beginning half I read first, and then I did the homework. But I spend just as much time. I just read it when I do the notes, and yeah, because usually it helps, like you said, better with a math lab. Okay, so the portion of the sphere, I need to draw this out. Anytime it has something like that, I have to draw it out, otherwise I don't quite get it. Okay, so square root 2 over 2 is what exactly? It's going to be 0.7 roughly, so it's not very high.
So we have z equal.
And then it's a sphere with radius 2. So we're going to get the whole sphere except for in the z direction. It's going to be kind of an open sphere, or a cutoff sphere, I guess, because I guess it's not a hollow sphere. See if I can even draw this. I'm still terrible at drawing in 3D. I shouldn't have done it that way. Okay, I'm gonna redo it. Then maybe I can see what we're doing. So
I know, where did the little box thing go? I hate it when I do that.
we're changing it into spherical coordinates. I never did much with those. Did you? I did the cylindrical, but
Yeah. Do you know how to make the little box up here?
where a box where?
The ones that have theta and pi in it?
I'm gonna go back to it. Okay, right here. Yeah, theta. So you don't need to worry about theta in the z direction, I don't believe. And I'm gonna have to solve in the cylindrical, but I think theta is gonna be, between 0 and 2 pi, because you still have to count for the x and the y direction completely. But for the z, it's going to be something different. Well, how come there should be 3, shouldn't there? You should have z bound. Oh, they only have 2.
Not in all of them. One of them has 3, so that's probably the one we need to choose.
Well, if that one's got 3, then how come it doesn't have bounds for z? Because they're already included, huh?
Yeah.
That's kind of stupid. Okay. Yeah, let me find my paper. I took notes on the other week. That already has all the information we need, I think. Let's see if I can find it. Let's see. It's not that one. Okay. Okay, so they're in the cylindrical. No, I mean spherical. So I don't know what. Okay, so in the x direction, I have what do you call that variable? I call it rho. There you go. Rho sine times cosine theta.
Sine times
That
cosine.
would be in the x direction, I think. So yeah, rho sine theta, cosine theta. The y is going to be. Oh wait, sorry. It's a omega or whatever that is. Phi, sorry. Sine phi cosine theta.
Well, I've been going off of the homework, and it says for x and y, it's just r cosine theta and r sine theta.
Well, it can't be because you see how it's got theta and phi in it, or whatever that is. I think that's what it's saying. It needs to be in the cylindrical or
Uh,
spherical. I mean, because that's how I was starting to do it too. But I'm pretty sure this is it. Times sine theta, and then it's just z. I think, right? No, this one's different too. It's rho squared and then cosine. phi, I guess. But I can't remember. Huh.
Sweet. Well, that's a
So,
little weird. I found the exact problem.
oh, did you on the homework?
Yes.
Awesome. The only thing I'm not sure of right now is the bounds for phi, because what I see right now is it's got to be between 0 and pi for the form that I'm trying to set up to work. And theta is going to be between 0 and 2 pi, because like I said, it needs to go all the way around the circles. Is this, yep, that's the one I need.
0 and 2 pi. Pi over 3 and 2 pi over 3.
Wait, what? Pi over 3 and 2 pi over 3?
Yeah, for the weird symbol whose name I can't remember.
I don't know. I've been saying phi. At first I said omega. Just call it, I think it's omega.
Also, with that one, it starts with a square root 2.
It starts with the square root 2?
Yep. All of them do.
What about in the third position? Here, I'll write out my formula just so you can kind of see where I'm at, and then you can tell me what's different from there.
Oh, that's probably what P is.
Is the radius basically?
Yeah.
Cause I think that is the case.
Except for it's not P squared.
That's what it has for the formula.
Mm,
Oh, it's just P, sorry. Or whatever. You're right. I was looking at a different practice problem. So that's what it should be, correct?
yeah, except for P is square root 2.
0 to A. So that means the bounds. Okay, so square root 2. Okay, so square root 2 isn't quite the radius, is it?
I am not sure. I do not understand this one at all.
Okay, radius equals square root 2. Oh, I guess, okay, I guess that does make sense. I was just going from the z, but we already have. I understand everything except for the square root 2, which, according to this, that's just the radius, but I thought it was something a little different. Okay, see, we're just parameterizing it, right? So we're not setting up an integral, so I guess that doesn't matter. I guess that's where I was getting caught up, is I was comparing it to setting up an integral. Well, let's look at this. Well, how'd that work? Radius equals A. Yeah, so it is the radius. Yeah, you are right. Which is root 2.
Yeah.
And it would be, the other part of the radius would be 0. So there's only these
That's why
terms.
it's just root 2.
So we don't have to subtract anything. As far as I can tell, I think that's everything.
Except for the P is, or not the P, the weird P.
Yeah.
Is between pi over 3 and 2 pi over 3.
Pi over 3 and 2 pi over 3.
Yeah,
What? That's weird.
the exact same question. It's not exactly what I meant to go do. They don't even
Yeah.
have a walkthrough for this particular one, which was annoying because that's what I wanted to know. I wanted to know how you're supposed to step through this problem.
So then I guess I don't understand these bounds. Let me look real quick. So why would we pi thirds to 2 pi thirds?
No clue.
Oops, that's not 0. I'm just trying to imagine why that would even be the case. Because you want to know the portion of the sphere between, radius square root 2. So it's going to be 0 to square root 2 for r, or p in this case. You want to know the whole circle, or the whole sphere, which is 0 to 2 pi. So that's right. But this sucker, I'm not sure. Like I say, I understand everything else except for that middle term. Because what I had was you pretty much want it to be between 0 and pi. I just don't understand that dimension. But hey, if that's what the answer is, I guess I'll just go with it for now.
Yeah, I mean, I don't get it.
I'm not going to be able to solve it. I know that much. Well, anyway, I mean, we were pretty close except for a couple things. The bounds being one of them, which is kind of important. I don't know. Well, want to go on to the fourth one? And
Yeah, I guess.
I mean, there's nothing else I can think to do.
Yeah, neither can I. So now we're going back to fluxes.
Okay, we have to parameterize it, so it's basically what we did do. Wait, no, this is a little different. Let's see if I've got an example. So this is the flux. Oh, I have it with doing the lines and stuff. So F is 4zk, right? So there's no x term and there's no I term, just the z term. Is that what I'm understanding?
It looks like to me.
So that's all in the F vector. 0, 0, and 4z. Okay, now we need to dot that with dr, but we need to find r first.
Holy crap, there's so much homework today.
Yeah, I know. It's a ton. I'm not going to get it done. I'll tell you that much right now.
There's 38 problems today.
It's a good amount.
Oh my gosh, really? Okay. I stumbled across almost the same problem.
Okay, that's awesome. If I can figure out
Before
how to set up
help.
the sphere.
Ah. First, parameterize a sphere using spherical coordinates with u equals theta and v equals the weird p. Pay particular attention to the values u and v for the given portion of the sphere. We call that the dot product of a and b, where a equals A1I plus A2J plus A3K quality F dot N should be expressed in terms of parameters U and V.
So the parameters are like the other equation we had, where our row, I guess, the small p angled, that one's going to just be A, correct?
Yes.
Okay, but it's going to be the same format. So our R of t should equal A sine phi cosine theta. No, it's going to be A, excuse me, A sine omega sine theta. And z is going to be A cosine omega. Okay, so when you take the derivative of all that, what are we taking it with derivative with respect to? Does it matter? If we do theta, then one of the terms is 0, then everything's 0. Well, that's just kind of obnoxious. Would it be better to take the derivative of x squared, y squared, and z squared first? Yeah. No, I guess that doesn't matter because we've already converted it.
Well, once we figure it out, I do have the correct answer.
You have the correct answer already?
Not me.
Oh.
Our homework.
Oh, gotcha.
But I don't want to just put in the correct answer. I want to understand why.
Yeah.
Why is it correct?
I just not. Oh, here we go. Let's see. No, that's the wrong part. Oh, okay. So the derivative, they do a huge determinant. It looks like to find the Jacobian. Oh, but that's just for that part in the okay.
Sounds
In
like
like the d omega d theta d whatever rho for that term in there. That's what they did. But
well, it
I'm
says
trying to
the
figure out how to
final
set it.
integral for the flux is 4 integral pi half and 0 integral 2 pi and 0 for a to the third cosine to the second v dot product sine v du dv.
Whoa, say that one more time. That was a lot of DVs and things.
Yeah, no kidding. Here, let me share my screen with you really fast.
Yeah, that might be quicker because the way I'm going about it is a little different.
As you can see, I was wrong.
Oh, I didn't look. Sorry. Mine was still on the group quiz. Go ahead and show it again one more time.
I am showing it.
Oh, I guess I couldn't. Why is it not? Oh, there we go. It wasn't showing me.
Weird.
So it said the answer was 1/2 pi a
That's
to the third.
no, that's what I said, and I was wrong.
Oh, it's 8/3.
Pi a to the third.
But okay, so you're pretty close. You're just off by a constant.
But it says that this is the final integral.
Yeah, here, let me write that down so you can see how to get to it. So that's pi half to 0 And that's 2 pi?
Yep.
0. A cubed cosine squared v dot sine v
Yep.
du dv. Now, why in the heck is that way?
I have no clue.
How in... And that doesn't show any steps, huh?
No, it just points you to the textbook.
I don't like our textbook.
Okay.
Every time I've tried to read it, it's just been worth it to surf for a video or to use the homework instead. Every time.
Yep.
Okay. I'm trying to even think how to set that up like that. I understand getting the a cubed, kind of, because dv equals, that's the volume, but that equals dx dy dz, which is going to equal our little p squared times sine omega. What I don't understand is how come there's only 2 integrals? Why aren't there 3?
I don't understand why there's even 2.
There should be 3 if it's spherical.
I assumed that it was 1 at first.
I think I might have an answer for the setup. Let me go back to last week real quickly.
Why last week?
Because where I took notes, it has a better, I guess, instructions on how to change your variables. So I think this is the right thing, because I'm finding a setup for it and it might help. But I didn't understand what I was writing down last week, really. Let me find it and then I'll share it. Oh, what part was that then? So I did the coordinates. Oh, so it's not this one, it's the other one. One second. So it's under the first thing, I think. Triple integral applications, possibly. Okay, it goes over cylindrical, spherical. Oh, I'm not sharing, am I?
No.
Here we go. All right. So this is kind of how he sets it up, but this is where I'm looking at from right here, setting up the integral. So all they did was they skipped a step with the rho squared.
Yeah.
So that's how they got the third, is because when they integrated rho with respect to rho, it becomes rho cubed over 3 evaluated from a to 0, which is just going to be
A
a
cubed.
cubed over 3. So
I thought,
now that we got sine
how'd they get rid of
omega.
the 3 though?
What's that?
How'd they get rid of the 3 though?
Oh, they moved it right here.
No, but I mean, oh, never mind. I know what's going on. I
Yeah.
got it.
So now it's this part where it's the phi, but I don't know the bounds on this one. But see, that's why I went from 0 to pi, because if you do that, then whatever value this is fine. Otherwise, you take the absolute value. So I'm not sure exactly the bounds on our problem, but something like that.
Well, I think it's a pi halves, didn't it?
Let's see. Pi half over 0 and 2 pi over 3. 2 pi to 0, I mean, sorry.
Yeah. So how'd they get pi half instead of pi?
I don't, like I said, the bounds for the middle term, I don't understand that at all. The other ones make sense to me, but I have no idea. So if the answer is supposed to be 8/3 pi a cubed, and I don't know how they got that 4 either. But
4?
yeah, I'm going to ignore that for now.
Okay.
Okay, I'm going to set this up just like we have this one. So 0 to 2 pi, 0 to pi, which is possibly just pi half, and then a to 0. Rho squared sine omega dp. Oh, I said p. Whatever. I'm just writing down the integral just like how it is and solving it by hand.
Yeah.
What are the other things for that? So there's nothing. Oh, it's the f is 4z.
Yeah.
So that's how they get the 4. So we dot that.
Yeah, that's what I was talking about earlier.
We dot that with dr. But why is dr 1 then? I'm not understanding that. Because the rho squared sine phi, whatever, that's something else. That's not. I don't know. I'm struggling on this one. Why does RT go to 1? Is that because you have to take a partial with everything? I don't know. If you do, then that's not quite the case.
No, that wouldn't make sense, would it?
No, not to me. I don't know. I'm not understanding that part right there. I thought I was getting it, but I know we dot it, but I don't know why it's just 4. Anyway, so that's why there's a 4 out there. I'll have to figure that out. I just want to see if I can do the integral right.
And the 2 comes from the 2 pi, which is why it's 8/3 pi.
Yep. It looks like you had pretty much everything right. Just that part right there, because you had 4/3, right? I didn't write your answer down.
Yeah. Yeah. I see where I messed up.
I just wish I understood the R of t and stuff. dr.
I just don't get where the pi half is coming from.
I don't know. I don't understand these bounds.
Where do we pull them from? I just don't get it. I mean, the 2 pi to 0 makes sense, but
Mm-hmm. Yeah, exactly.
How do you tell if it's pi half, pi, 2 pi over 3? I don't know.
I'm not sure on that one. Like I say, I don't even know what that really represents. I know it's supposed to be the y
Yeah.
direction, kind of, but at least in my mind. But to me, it just doesn't make any sense.
Oh, wait a second.
You got it figured out?
Is it from the phrase where
Oh,
x
where
positive
x is positive in the
is
direction away
away
from the
from the
origin.
origin?
That's why it's 0 to pi half. See that part right there?
Yeah.
I didn't even read that till just now because you said the phrasing like a phrase.
Yeah.
Okay, so let me go at it. So pi half 0, and that's a cubed over 3.
So I just realized the phrase in the homework is in the first octant in the direction away from the origin.
The first octant, huh?
Yeah.
So that would be pi over 4
Except for in the homework it's pi half.
for an octant. That's an eighth. That doesn't make sense. They should say the first quadrant then. Huh? Maybe it's just terminology. I don't know.
I don't know either. Yeah, I'm gonna submit the quiz to see if this is even right.
Yeah, you're good. Just gonna go.
Yeah. Yeah, it's correct. Except for we missed question 1 somehow.
All right. Give me 1 second to where you're at.
What? That doesn't make sense.
Okay. Question 1 is wrong. How does it want it done?
They have it as 4xy plus 3xz plus 2yz.
What?
That doesn't make sense.
So it's half of that?
Yeah. I'm going to email the professor and ask him about that because that seems wrong to me.
Why would it be half? What's the thing about potential here? There's got to be something because
I don't think so because none of the homework does it that way.
yeah, you might be right. But I'm just gonna submit mine the way it is too. Just call it good. Because if it's the right way, I mean, what's the point in doing it wrong?
Yeah.
I don't know. It really doesn't make sense. Hmm. All right. Well, I have no idea on a lot of these. Now I got it figured out with that term, but I may have just done the pi half in a different direction. I don't know. Hmm. I really wish I understood the FDR on this one. I just don't understand how come there's not a Z in there, too. It's kind of weird.
Alrighty. Well,
Well, we had a lot of fun today, huh?
yeah, we got through relatively quickly.
Yeah, not too bad.
Well, next week's the quiz or the test.
Yeah, I think I've got another test next week, too,
Oh, that's fun.
for my other math class, so, yeah.
Oh, even more fun.
Yeah, oh, yeah. That's how it works. They basically have, like, the same due dates and everything, so,
That kind of sucks. I'm sorry to be
yeah.
going through that.
A little bit, yeah. They both require a lot of work, so it's just kind of how it works. All right, well, I will harass you Monday sometime and let you know for sure. But I'm definitely planning at least 3 hours for Wednesday.
Yeah,
And if you want to meet a little earlier, a little later, whatever.
yeah. I probably good if we plan on 10, and then I'll just
We can play it by ear too, and if we need to take a break and then meet later, we can.
yeah. I mean, that might be good to break for lunch or something and then come back to it.
Right? Yep. That's fine for me.
I would like you. Whoa, what?
What's that?
Uh, he has the or the exam opening Wednesday and closing Thursday. Oh, wait a second. We can we turn it into the drop box by Saturday. That means we can't look at it till Wednesday.
So Wednesday's the earliest we can look at it.
Yeah, and if you don't get it on Wednesday, you don't get the test.
Really? Wow.
Well, actually, it's by Thursday at 11. So hopefully everyone realizes that.
So that's when it's due is 11, or that's
No, no, no. You can only download the test between Wednesday at
oh,
noon
I see.
and Thursday at 11 p.m.
Okay, I thought that was the case, but then I thought it was also due. Then I thought that's not a lot of time.
No, the Dropbox is where you turn it in, and that ends April 6th at 11. So,
Ooh, that's gonna be an intense week. And isn't that general conference too?
yep.
Oh my heck! I got two crazy tests like that are gonna take all my time. Conference weekend.
And then the next week, we have the review for the final exam if
No,
we,
that'll be fun.
if we want to meet up and do that.
Yeah.
I
Anytime I meet, it seems like it helps me understand quite a bit better. So
Yeah, I do better on the test when I meet with you. I mean, I still haven't done well on the test compared to you, but
I I don't know why they're lucky. And you're the opposite for quizzes. You do better on quizzes than I do. This last one, I know I didn't do that good.
oh, I sucked at this last one too. I think I got to 60%.
Yeah, it's
The worst
crazy.
that I've done
You
all.
wouldn't think it would be that hard, but I don't know. They are. They're ridiculous.
And then week 5, I randomly got 48%.
That's not good.
Well, I did the corrections and got 18 out of 20, so like 90%.
Oh, that's not bad then. Yeah, I kind of like how he has that. You can do the corrections
Well, I think
and
that it really helps you learn too.
yep, I agree on that.
And it's funny, we have like perfect scores in all of our group quizzes except for last week.
Yeah, that one was just
That was
I
so
don't know.
hard.
Yeah, I don't even think I could still pass it. It just doesn't make sense.
This week was way easier compared to last week.
I think it's just the line integral concept that's a little hard to understand.
Well,
At least for me.
Makes it seem like the test is going to be a pain.
Anytime it's a take-home test, it's usually more work than it's worth.
But he said that everyone in his class has always gotten a higher score on this test than any other. So, as long as we take the time and work it out, I think that it'll be good. I'm really hoping to get like a 75 to an 80 at least.
Yeah, let's just shoot for 100.
I would be down for that. Because if I got 100, I could bomb on the final and still pass this class. And then I would graduate. So
yeah.
I would really like to do that. So bad.
That'd be a little nice to graduate. Well, we'll get it worked out, and we'll make sure that we help each other out on that test and get as high a score as we can get. I think we'll do pretty good. We might have to spend more than 3 hours, but
I am willing to spend whatever we need to get a good score on that test. I will budget the entire day if I have to. All right. Well,
I'll try to look at it as soon as I can, but
yeah, I'll take a peek on Wednesday.
Yeah, so we can't really look at it sooner and then meet together and make it quick and efficient. So,
alrighty. Well, I'll see you next week.
All right. Have a good one. I'll send you the link in just a second.
Awesome.